What's up?
Yes.
Yeah, it's pretty good.
Yeah. Oh yeah, pretty, yeah.
Hello? Everybody. Hi, thank you for coming. Really appreciate it. This is we're going to have our behavioral economics seminar, and we're very happy to have Wesley Pech with us, who's going to teach you. I'll introduce you in a second. A couple things I want to tell you. We have on Tuesday at 4 o'clock, in November 14th, we have our Gamble lecture. And the economics department is looking for a few people that would be like to put up some flyers, about 20 or so each. And you'll be paid for that position just to go out do flyers. So if anyone's interested in that, I'll circulate a paper, see if anyone's interested in that. Also make sure you go to this because Tuesday at 2 o'clock in May 19, we're going to have our alumni meet and greet. And it's a chance to meet alumni, find out what all they're doing, and it's a really great event. I hope you guys come. Now let me introduce Wesley. If you ever, I don't know if you've had him as TA, he's probably one of the best in the department.
Oh yeah, yeah.
Hands down. So he's going to be teaching a course we both fought really hard for with the UEC, and we got it approved. And so we're going to have a course on behavioral economics. It's going to be in the spring semester. And it's going to be a 3-credit course, and it should be on Spire sometime within the next couple of weeks. So definitely look for that, and I hope you enjoy the seminar. Thank you.
Wonderful. Thanks. Well, hey, I don't know if you know, but Bob Schiller is also a behavioral economist. So he's probably going to talk about behavioral economics. What I did was to select a few examples of how we can incorporate psychology into economics. And I actually chose the easiest ones to understand. The coolest, cooler ones, but more difficult ones. Anyway. What is the definition of behavioral economics, also called economic psychology? The combination of psychology and economics that investigates what happens in markets in which some of the agents display human limitations and complications. Actually, I don't like this definition much because if you look at the definition of economics, let's say what is economics? Well, allocation of scarce resources. So basically, it's the size of decision making. Right? Am I going to buy an apple or a pear? I'm going to eat an apple or a pear. I'm going to buy a house now or 5 years from now. So all these decisions are relevant to economics. And therefore, we have to understand what happens when we make these decisions. Traditionally, economics uses maximizing behavior to explain the decisions. So what do consumers do? They maximize utility, right? 203, utility maximization. Profit maximization, firms maximize profits. But do firms really maximize profits? Do consumers really maximize utility? Are people rational? I mean, don't we make mistakes sometimes? Yes, we do. But behavioral ideas are not new. If you look at Adam Smith, the father of economics, you only know the wealth of nations. Well, there's a less known book called The Theory of Moral Sentiments. Actually, he wrote this book 17 years before the Wealth of Nations. And it's bursting with insights about human psychology. And a lot of these ideas were just ignored. I mean, let's look only at the Wealth of Nations. Let's forget about the Theory of Moral Sentiments. But now there's been a revival of these ideas on the Theory of Moral Sentiments. So after Adam Smith, of course, we had a lot of economists that tried to understand how people behave. But the death of psychology was happened through the late 19th century with the neoclassical revolution, which is economics that we use today. Everything that you learn in microeconomics is neoclassical economics. So the neoclassical revolution says that, well, not as said, but they assume that people are rational. So If I want to make a decision, I am able to calculate what is the optimal solution, and I'm going to make that solution. People are self-interested. I only care about my own payoff. I don't care if you earn more money than I or less money. I only care about my own. Some economists disagreed with these ideas at that time. So we had Thorsten Veblen, the theory of the leisure class, 1899. And he had some insights about human psychology as well. And of course, Keynes. I don't know if you know Marcel, who had a class with Marcel, another Brazilian part. But I and Marcel are working on a paper on the behavior economics of Keynes. I mean, people completely ignore the psychological insights that Keynes made about human behavior. Now I'm trying to analyze these insights. But basically, after World War II, there was no psychology in economics. I mean, people are rational, and that's what matters. Because it's simple, right? I mean, neoclassical economics is beautiful. I think it's beautiful. I think it's false. I think it's wrong, but it's beautiful. I mean, when you look at profit maximization, all those curves, tangencies, equilibrium point, it's beautiful. It happens. I mean, you can explain the real world in simple terms. But it's just wrong. I mean, people do not maximize utility. Firms do not maximize profits. And we are not rational. We are not even selfish. I mean, I care about the payoff of my parents. But neoclassical economics does not assume. Right? So, after World War II, Herbert Simon was the first that had some impact on us getting this psychology into economics. He created a term called bounded rationality. We have only so much brain power, only so much time, and therefore we cannot optimize all the time. So we are bounded rational. If we cannot make these optimal decisions, well, he uses some rules of thumb, which now we call heuristics. What are these rules of thumb? Well, I need gas. My car needs gas. So do I think what is the optimal gas station to go? What is the cheapest one? And I have to calculate the transportation cost to go to this gas store and whatever. No, we just say, well, there is this gas store which is close. The price is relatively good. I'm going there. Right. So these rules of thumb are ways in which we guide our behavior. But then the behavioral revolution happened in the 70s. Daniel Kahneman and Amherst, actually they are not economists, they are psychologists. Amherst is the other way. But Daniel Kahneman won the Nobel Prize in 2001 in economics, and he's a psychologist. Herbert Simon actually won the Nobel Prize in 1978. The first revolution happened in 1974 with heuristics and biases. There was an article saying that, well, people use these rules of thumb to guide their behavior. We only satisfy. So we don't, instead of maximizing our utility, I say, well, this is good enough for me, I'm going to stop it. And they said that if people really use these rules of thumb, they can lead to systematic behavior. And this systematic behavior can have errors. So we can make mistakes sometimes. And I'm going to show some examples of how this makes sense. 5 years later, they created a theory of explaining judgment under risk. And it's called prospect theory. I'm going to show some examples as well. And after that, with the behavioral revolution, all major economic departments in the United States have at least one behavioral economist. Umass had two. Samuel Bowles and Herbert Ginzes. Unfortunately, they are Americans, but they were behavioral economists. But no, Umass doesn't have any behavioral economists in the faculty. The students would have this. So what are the methods of behavioral economics? I mean, of course, if you're using psychology to explain economics, we have to use some of the psychology methodology, right? We just use experiments. So behavioral economics uses a lot of experiments. 50 years ago, nobody thought that we could explain the economy using experiments. I mean, how can you do experimental research in economics? what happens in the real world. But actually this was a major revolution that happened in terms of methodology in economics. Now people go to the lab, we have a lot of computers make decisions, they are paid to make these decisions, and it's incredible how they can predict what happens in the real world. I mean, external validity is almost perfect. Nevertheless, behavioral economics is not the same as experimental economics. Experimental economics is methodology. I'm going to use experiments to explain everything. It's industrial organization, behavioral economics, whatever. And behavioral economics is about incorporating psychology into economics, using experiments or without using experiments. Right? So I'm incorporating some insights from psychology to economics. It can be a theoretical work. I can use brain scan. Neuroeconomics is a very new field. We use brain scans to explain what happens in the brain, to explain decision making. Field data, field experiments, computer simulations. Behavioral economists use all these tools and experiments as well. So that's the difference between experimental economics and behavioral economics. Behavioral economists use all the tools that we use in economics, but we use insights from psychology. And experimental economics is the methodology. I'm going to use experiments to explain anything with the results. And when we use experiments to explain the economy, these experiments are a little bit different from the experiments that are used in psychology. Two basic differences. First one, you receive money to participate in this experiment. So if you're going to participate in my experiment for my dissertation, if you go there, you're going to receive money. Right? And the better your decisions, the more money you're going to get. Psychologists do not pay the subjects. So it's a main difference. It's not that it actually improves rationality. I mean, it's proven that it doesn't matter whether you're paying or not. The only thing that differs is that the standard deviation decreases, so that there is less variance when you pay the subjects. But it doesn't improve rationality. In the second, there is no deception. You know that psychologists deceive people all the time. I think it's silly not to deceive in economics as well. I mean, a lot of ideas in the lab we can understand by using deception. And it is proven in psychology. But somehow economists are reluctant to use deception and experiments. Okay, so now the main findings. Now the fun starts. Okay? I was talking about Herbert Simon in 1955 that said, well, since we are we have bounded rationality, we use these rules of thumb, which are heuristics basically. So these rules of thumb, it is a good thing and a bad thing at the same time. I mean, to use these rules of thumb, it is good because you can have fast and near optimal solutions to very complex problems. But at the same time, these rules of thumb can lead you to make systematic mistakes. Daniel Kahneman and Amherst in 1974 realized that people use basically three heuristics. Representativeness, this one, availability, and answer. Representativeness means that, well, if we want to make a decision between what is the probability of an object A belong to a class B. So what is the probability of an event A happen in situation B? And in order to assess this probability, what people do is, if it is similar, it is very likely. If it's not similar, not very likely. So let's consider this example. Well, consider an individual who has been described by a former neighbor as follows. Steve is very shy and withdrawn, invariably helpful, but with little interest in people or in the world of reality. A meek and tidy soul, he has a need for order and structure and a passion for detail. How do people assess the probability that Steve is engaged in a particular occupation from a list of possibilities. For example, farmer, salesman, airline pilot, librarian, or physician. So, what the psychologist said is that, well, I know how Steve is, so what is the occupation that looks more like Steve, right? Does Steve look like a farmer, a salesman, an airline pilot, librarian, or a physician? What do you think?
Librarian.
Maybe physician, but I would say that definitely a librarian, right? So you say, well, if I had to bet, what is the profession of Steve? I would say he is a librarian, right? What is the problem? You see, it is easy. It is a rule of thumb. I mean, if it's similar, it's more likely, right? So Steve is shy, so he's probably a librarian. Why is librarian not the best option? I would say that it is much more likely that he's a salesman instead of a librarian. Why?
I don't know. As a salesman, he says he's helpful, but with little interest in people. I mean, I don't think salesmen are really that interested in people. They're just trying to make a sale.
I mean, it can be, but not really. No.
No.
Any more? Thanks. Well, Phil.
There are more salesmen than librarians?
That's the point. The base rate, right? So let's say we have 1,000 librarians in a sample of the population, and we have 100,000 salesmen, which is maybe true. I mean, we have much more salesmen than librarians. And let's say that 90% of the librarians are shy or withdrawn, whatever, right? Because it's very representative of librarians. So you would have 900 librarians. And let's say that only, 5% of the salesmen are shy and withdrawn. Almost nobody, only 5%. So we still would have 5,000. So it's much more likely to find a salesman that is shy, withdrawn, very helpful, and all the other characteristics than a librarian because of the base rate. I mean, this example shows that we do not pay attention to everything. So we're not maximizing. When we assess the probability of something, will my firm have a 10% profits or 20% profits? Maybe we're not taking into account the base rate of the firms in my industry. We're not taking into account how many firms this industry has. Okay? So that's one of the rules of thumb that we use. But again, I'm not saying that it's a bad thing to use this. It is a good thing and a bad thing at the same time. For most cases, it works. I mean, I use representativeness all the time. But I am aware that sometimes I can make mistakes using it. So the second one is availability. This is a symbol. Availability says that we think that the easier it is to remember a thing, the more likely we think it is. I mean, when you're assessing judgment probabilities, what is more likely, A or B? If we remember A more easily, we think that it's more likely to happen, right? Instead of something that we don't remember. I don't remember anything of this case, so it doesn't have to be very likely to happen. But if I remember something easily, I think it's very likely to happen. So most people think that homicides, which are highly publicized, are more common than suicides. But in fact, it isn't. We have much more suicides in our society than homicides. But the problem is that you see in the media homicides all the time. It's much easier to remember. Right? I mean, I am not able to say 5 suicides that were in the media. I just can't say. But home size you can remember all the time, right? Everything's. And the third one is anchoring. I mean, this is beautiful. When we have to make an estimation, an estimate of everything. I mean, I want to sell my used car. Well, how much am I going to charge? How much do I want for this car? Well, so it's used. I'm going to see the price of a new car, equal but new. Then I say, well, it's $20,000. And then I make, well, a new car is $20,000. Mine is 3 years old. So I make an estimate. I adjust this 20,000 downward to say how much I want. Right? Again, it's a very useful heuristic, but there are some traps with that. So in a recent study, these economists that published this paper, they sold valuable consumer products. They were selling 100 wireless keyboard, a fancy computer mouse, bottles of wine, and a luxurious box of chocolate to MBA students, people who are going to make decisions in the firms. Right? The students were presented with a product and asked whether they would buy it for a price equal to the last 2 digits of their own social security number. So a number that is irrelevant. It's irrelevant, right? For how much I'm willing to pay for a bottle of wine. So if, for example, if the last digits were 79, the hypothetical price was $79. After giving a yes or no response to the question, would you pay $79? So let's keep going. Subjects were asked to state the most they would pay for this good. And what happens then? Although subjects were reminded that the social security number is essentially random, it is irrelevant, those with high numbers were willing to pay more for the product. In one of the examples, subjects with numbers in the bottom half of the distribution, so those with the two digits, like 10 or 12, priced a bottle of wine, that bottle, at $11.62, while those with numbers in the top half priced the same bottle at $19.95. Just irrelevant. And you see this every time they reward clearance. Right? Go to any department store and you see, was $40, now $15. Wonderful, I'm gonna buy it, right? Because you are adjusting, but you're not adjusting enough. So you're using a rule of thumb that is good, but it can make some mistakes. So 5 years later, so these 3 heuristics were reported in 1974 for the first time, and it caused a revolution. And 5 years later, there was a second revolution with the same guys, and it's called prospecting. I think that for those who used Frank's book in microeconomics, in intermediate micro, must have seen this. What is this graph? It says the following. In a series of events, instead of considering the final wealth situation, we separate gains from losses. So for example, I have no money in my pocket. And I'm walking over the street and I find a $50 bill. I'm certainly better off, right? $50. But for some reason, half an hour later, I lose this $50. Where's my $50? Right? Notice that my final position is the same as my initial position. I have no money in my pocket. But do I feel the same? No, I don't. I mean, your classic numbers will say, well, if you have no money in your pocket in one situation, you have no money in your pocket in the second situation, you should feel the same. But this is not true, because we do not consider the final wealth position. We consider, well, there was a gain, and then there was a loss. There are three characteristics of this graph. The first one is that losses loom larger than gains. You can see that. So let's say that this is $50. The gain of utility by having $50 is this amount. But the disutility of losing $500 is much more. Right? So losses loom larger than gains. The disutility of losing $50 is greater than the utility of acquiring $50. So at the end we are worse. So the second situation is that the important thing is the reference point. When I found the $50, my reference point is not here. My reference point is here. So I have $50, and now when I lose this $50, it's not that I'm back to this point. It's not that I received $50 and then I lost $50. I received $50, then I came back to this point, then I lost $50. So you always come back to the reference point. The next thing is that changes your reference point. We never aggregate decisions. And the third feature of this graph is that we have diminishing sensitivity. The difference between having $1,100 and $1,000 is less than the difference between having $200 and $100. And the same for losses. The difference between having to pay $1,100 and $1,000 is less than the disutility of having to pay $200 and $100. So you have diminishing sensitivity when you increase your loss or when you increase your gains. The main implication of this situation is that because of that, we are risk averse for gains and risk seeking for losses. One of the examples. One situation you have to choose. Do you prefer a sure gain of $100, or do you prefer a 50% chance to gain $200, or a 50% chance to gain nothing? As you can see, the expected value of these two situations are the same. Right? If you multiply 0.5 times 200, you're going to find $100. So neoclassic economics will say, doesn't matter which one you prefer. What happens is that most people are risk averse for gains. So 72% chose the sure gain instead of betting for the 200. But if you frame this situation as a loss, so what do you prefer? A sure loss of $100, or a 50% chance of losing 200, or a 50% chance of losing nothing? The opposite. Now, suddenly people are risk-seeking. They are taking the risk in terms of losses, but they're avoiding risks in terms of gains. Right? So this graph implicates that we are risk-averse for gains and risk-seeking for losses. And of course, neoclassical economics will predict that there's no right answer between A and B in both situations. But if you chose A in the first situation, you had to choose A in the second, or B in the first and B in the second. But not A in the first and B in the second. That's inconsistent. Prospect theory, it seems simple. Oh, losses loom larger than gains. But we have a lot of implications of that. Since the losses are more important than gains, a lot of things can happen. One of the examples is the framing effect. So if you frame something as a gain, and suddenly you frame it as a loss, even if the situation is the same, people can make very different decisions. This is the famous Asian disease problem. Some of you must have seen it because it's incredible. So participants were asked to imagine that the US is prepared for the outbreak of an unusual Asian disease, which is expected to kill 600 people. 2 alternative programs to combat the disease have been proposed. And people have to decide which one to actually put into action. Assume the exact scientific estimate of the consequences of the programs is as follows. The first group of participants was presented with a choice between two programs. So you have to choose both. Unfortunately, we cannot save everybody, so you have to choose between saving 200 people for sure, or you can save everybody, 600 people, with a probability of 1/3, but you have a 2/3 probability of saving nobody. 72% of the participants prefer program A. Let's save 200 people for sure. And the remainder 28 opted for program B. Then the second group of participants was presented with the choice between problem C. Do you prefer that 400 people will die for sure, or a 1/3 probability that nobody will die, or a 2/3 probability that 600 people will die? As you can see, the two situations are the same. Saving 200 people is the same as killing 400 when you're expecting to kill 600. And 1/3 probability of saving everybody is the same probability that it's the same as 2/3 probability of killing everybody. What happens is that when you frame it as a loss, people prefer this situation. I mean, public policy. I mean, the government can manipulate people into making some kinds of decisions, right? Whether you frame it as a gain, whether you frame it as a loss. Notice that when you frame it as a gain, people are risk averse. They don't want to bet in a situation in which you can kill everybody. Oh, let's save 200, it's fine. But when you frame it as a loss, people prefer to bet. People prefer to take the risk, even if the situation is the same. Now the sunk cost effect. Neoclassical economics says that historical costs should not influence future decisions. I mean, if you spend some money on a good or whatever, this money that you spend, if you cannot recover this money, should not influence your future decisions because it's lost. But that's not what happens. So, for example, suppose that you are in the process of deliberating about how to spend the remainder of a given evening. You might attend a theater performance. Alternatively, you might remain at home and read a novel. So you have these two options: go to a theater or not go to. After careful reflection, you conclude that although you would enjoy either one of those activities, you would derive somewhat more enjoyment from remaining at home and reading the novel. So say, I can go to the theater or not. Well, it is raining, I don't feel much like going, so I don't go. Right? So, in these circumstances, it would seem that remaining at home to read a novel is the rational choice. All else being equal. And it is. Because you prefer to stay home. Here, however, is a further fact about your circumstances. Some time ago, you purchased a ticket to this evening's theater performance at what you regard as a high price, say $200. So the difference now, you already paid for this ticket. Right? $200. And it's the same situation. It is raining or snowing or whatever. You don't feel like going, but you paid $200. Would you go or not?
I totally understand the whole sunk cost idea where it's like, hey, it's all you can eat. You might as well not eat another slice because you already paid that.
Yes.
You know? But in this case, like, at this age when you don't have that much money, it's like, hey, I'm not going to have another opportunity to pay for that again. So I kind of can see it. Although it's not rational when you think about it, I can kind of see that being like, all right, $200 on this. I I'm not maybe able to do that again in the future, so maybe I won't do it.
That's right. And I'm with you. I'm with you. I mean, behavior economics is not about how people should make decisions. It's how people make decisions. I'm not saying that being irrational in the neoclassical sense is bad. I mean, I am irrational, and I don't care. And I think it's much better. Actually, in behavioral finance, I mean, if you take the course, you're going to see that. Irrational investors generally make much more money than rational, right? Sunk cost, maybe it's an evolutionary thing. I mean, when we were hunter-gatherers, to honor sunk costs could have been a good thing, right? The thing is that the world that we live in today is the one that thinks that sunk cost is irrational, but that's not true. So the main thing is that people behave like this, and therefore you have to explain the economy knowing that. But I'm not saying that you should avoid sunk costs. But in this situation, so you pay $200. So unfortunately, the ticket is not refundable. Moreover, it is now too late to keep the ticket away or to resell it. If you do not attend to tonight's refunds, the expensive ticket will be wasted. So neoclassical economics will say, well, the price of going to the theater and the price of not going to the theater is the same, right? $200. If you don't go, you spend $200 because you cannot resell the ticket. If you go, you're going to spend $200. So the price is the same, and you prefer to stay at home, you have to stay at home, even if you have paid this $200. So that's not how people behave. People honor some costs. So historical costs influence future decisions. And this happens because losses loom larger than gains. I mean, I am going to the theater because I feel like losing $200 if I don't go, right? And since losses loom larger than gains, I go to the theater. So this is explained by prospect. Now, I have two effects here. This might be a little bit technical, but if it should, I go, I get scared. But anyway, this graph represents an effect that is called the endowment effect. Well, again, since losses loom larger than gains, the amount that I demand to give up one good that I have is greater than the amount that I'm willing to pay to have this good. And, I mean, a month ago happened something, it was funny because it happened with my wife. I mean, she asked, Wesley, do you want a yogurt? And I said, oh, of course, I want one. She would have some. And then I think she got a raspberry yogurt for her. And she said, well, what flavor do you want? Any flavors. And then she got me a strawberry with white chocolates. And then, okay, she had her strawberry yogurt. And then she said, well, I want a spoon of your yogurt. And I said, okay. She tasted my yogurt. And she said, oh, yours is better. And I said, do you want to trade? No. You see, when you receive a good, you think it's valuable for you. You demand much more to give up this good that you already have than what you are willing to pay to acquire this good. Because if you like losing this good, and remember, since losses loom larger than gains, you don't want to lose it. So what happens is that in this example, some people receive pens and some people receive money. Those who received pens had to trade for money. So you have, let's say, 3 pens. Are you willing to trade 3 pens for $3? No. For $4? No. $5? Yes. So in doing these questions, we can actually come up with an indifference curve. Right? And for those who receive money, the same thing. You have $5. Do you trade $5 for a pen? No. For 2 pens? No. For 3 pens? No. 4 pens? Yes. So then you have an indifference curve. And I'm sure those who are taking 2 or 3 now with me knows that. So in indifference curves, you have good X, good Y. for y, for y, for x. And then having this indifference curve, right? Which implies that it is reversible. If I start with a lot of x and a little of y, and then increase the amount of y that I have and decrease the amount of x that I have to stay on the curve. Right? If I start with a lot of y and a lot of x, and then decrease y to have more of x, I have to reach this point. Right? It is reversible. Doesn't matter where I start, the indifference curve has to be the same. Because what? If this is not true, indifference curves would intersect, which you know that is a sin. Indifference curves cannot intersect because it violates what? 2 or 3 students here. It violates what? If indifference curves intersect, it violates what property? Exactly, transitivity. Right? It violates transitivity. And that's what happened. Again, just some, this indifference curve. Give x. So this is y, this is good x. Does this person prefer y or x more? Does this person have a preference for y or for x?
X.
Isn't that where they're different?
No, it is an indifference curve. But this indifference curve can tell you a lot about the preference of the consumer. Yes?
I think it's x.
Why?
Because you're willing to trade a lot of y for just one x.
And that's it. This person prefers x more than y because to receive one more unit of x, she's willing to give up a lot of y. And of course, this is the opposite, right? In this case, the person prefers more y than x. But she's willing to give up a lot of x to have one of them. So note that when people started with dollars, they came up with this indifference curve. They preferred much more dollars than pence. I mean, once they received the dollars, I have dollars. I'm not willing to give up this dollars for some pence. Right? Now, those people who receive pence said, I have pence. I'm not willing to give up this pence for some bucks. Right? And what happens that indifference curves cross? People violated transitivity. If A is greater than B, if B is greater than C, I don't know what I'm going to do. Okay, so this is the Endowment effect. An effect similar to the Endowment effect is called the status quo bias. The status quo bias means that people have a preference for the current state. If you make some option as the default option, people are reluctant to change this option. So you say, you inherited some amount of money from your uncle, and it's good money. And then you can choose to invest this money in a high-risk portfolio, medium-risk portfolio, or low-risk portfolio. If you ask people this question, they will say, maybe a third will choose high-risk, a third will choose medium-risk, and a third will choose low-risk. But if you say, well, you inherited this money, but this money is already invested in the high-risk portfolio. Do you want to change it? No. See? The status quo, when you say that it is already in one option, the high-risk portfolio is the default option, people are reluctant to change. Incredible. This is incredible. You know, I got my driver's license here, but I don't know how it works here in the United States. These are United States. But you have to make an option whether you want to be an organ donor or not, right? What is the default?
Not.
To not, so you have to opt in, right? For these countries here, it's Denmark, Netherlands, United Kingdom, Germany. You have to opt in. The default option is that I am not an organ donor, so I have to opt in. Almost nobody. For these countries, you have to opt out. The default option is that you are an organ donor, you have to choose if you don't want. It's just an X on the square, right? Either you want or don't want. But when the default option is that you are an organ donor, nobody refuses to be. So the way you frame it as a default option or not cause huge changes in the decision making. The next one is asymmetric dominance. Well, dominance says that if something is better if A is better than B, I'm going to choose A. Or, in other terms, if something is irrelevant, it should not influence. So, for example, you go to a restaurant and you say, well, I want a sandwich. What kind of sandwich do you have? Oh, I have tuna sandwich and turkey sandwich. Tuna and turkey. I want tuna. Oh, I forgot. We also have roasted beef sandwich. Oh, no, I want turkey. You see how it's inconsistent? I mean, the option of having roasted beef should not make you change from tuna to turkey. It's funny, you know. So some people receive this option. You have to choose between two kinds of burgers. The nutri burger, which is a burger made from tofu and other vegetables, that is rated very good on nutrition, I bet, but only average on taste. And letter B, tasty burger, a hamburger that is rated very good on taste, but only average on nutrition. Okay, so one side is so far so good. The decision is a clear one. If you want good taste more than good nutrition, you go for the tasty burger. If nutrition matters more, you go for the nutri burger. And in this experiment, roughly half of the students select the tasty burger and half select the nutri burger. So far so good. Right? Half chose one, half chose the other because of practice. But then he says, well, but suppose that we're working for the makers of tasty burger. How might we make it more attractive? Then he says, by inserting a decoy. So you still have to choose between nutri burger and tasty burger. But they included a third option, the bummer burger. Which is a hamburger that is rated only good on taste and only average on nutrition. I mean, the bummer burger is an irrelevant option. It is dominated by the tasty burger. Right? Tasty burger is very good on taste. The burger is only good on taste. And tasty burger is average on nutrition, and bummer burger is also average on nutrition. So tasty burger also, of course, dominates letter C. And of course, nobody chose the bummer burger. Nobody. But what do you think that happened?
It's a reference point.
So what happens?
So you just decide, well, you're deciding between a tasty burger and a bummer burger instead of the.
No. The burger, nobody chose the bummer burger. Because it's so bad that it's so hard. But what happened between the two? It was 50-50.
You get more people wanting the tasty burger.
80 people chose the tasty burger, and 20 people chose the nutri burger. How can I explain this graphically? So we had, this example is for apartments. I'm going to talk about the apartment example. But we had, so instead of choosing burger, you have to choose between two apartments. One that is close to the campus but expensive, and another one that is far away from the campus but cheap. A and B. So let's say, far away from the campus, cheap, closer to the campus but expensive. And we have 50-50 on average. Then let's insert one in which it is even further from the campus than B and even more expensive. Of course, nobody will choose C, but a lot more people choose C. So actually, if you have a firm and you want somebody to buy more of your good, you just add one more good that is nobody will buy it. But because you want people to buy the other one, right? Yeah. When I finished my undergraduate course in Brazil, I replicated this, the same example. I did a lot of these experiments in Brazil. And actually, it was so funny that 6% of the people chose this experiment. It's unbelievable, right? Okay, if you are fooled by something that you can't avoid, but it's clear the third apartment. So notice how all these examples can be explained by looking at reference points and the difference between losses and gains. And the same as this one. So mental accounting. Mental accounting is said that the way people store information in their head about how to spend on something. So instead of treating it as only one account, so instead of putting all your money in one account, you put out, this is money for my health, this is money for my education, this is money for my leisure. And people do that. You differentiate accounts for different situations in your head. And it is easy to make decisions when you do this, but can also lead you to some errors. So in this example, it said that you are lying on the beach in a hot tub, water. All you have to drink is ice water. For the last hour, you have been thinking about how much you would enjoy a nice cold bottle of your favorite brand of beer. If you don't drink beer, whatever you like to drink. A companion gets up to go make a phone call and offers to bring back a beer from the only nearby place where beer is sold. Then, half of the people said that this beer is sold in a fancy resort hotel, and the other half was told that this beer is sold in a small, run-down grocery store. Okay? He says, your companion said that the beer might be expensive, and so asks how much you are willing to pay for the beer. He says that he'll buy the beer if it costs as much or less than the price you state. So you say, well, I'm willing to pay this much. If the price is this much or less, he's going to buy it. But if it doesn't know the price you state, he'll not buy it. You trust your friend, and there's no possibility of bargaining with the bartender if it's in a fancy resort hotel, or a store owner if it's in a small run-down grocery store. What price do you tell them? Notice that the beer is the same. It doesn't matter whether you buy from a fancy resort hotel or a small or a grocery store, the beer is the same. But what happened is that the median responses for the two versions were $2.65 for a resort hotel and $1.50 if it's in a grocery store for $1984. And I replicated this in Brazil, the difference was even greater. It was like $3 for the store, and $8.50 for the fancy resort. If it's a fancy resort, I'm willing to pay that much. Notice that this is considered irrational, because if you're willing to pay more for the same good in different situations or different locations, you might end up not drinking the beer that you want because of some inconsistent that you have in your brain. And so the explanation that note that this effect cannot be accommodated in a standard economic model, because the consumption experience is the same in either case. The place of purchase should be irrelevant, but it isn't. I mean, mental accounting is incredible. There are a lot of examples of mental accounting. People are willing to save $5 on a $20 calculator, but they are not willing to save $5 in a $1,000 TV set. Since you're saving $5 in both situations. For this example, those who read Freakonomics, it is a Freakonomics. The role of incentives in economics. What is it? Well, people are simply doing wrong. If there's something doing wrong, how can we stop it? Fine. So If you pay a fine, you're going to do less of that. If people are doing something good, you have to reward them. Right? So, what does this graph say? In Israel, two economists, they went to 10 daycare centers, and they observed that there was some, the parents were arriving late. And they, in 6 of the 10 daycare centers, they said that if the parents arrive 10 minutes late, they're going to pay a fine. It was a small fine, because they made $10 each day. So, the white squares are the daycare centers without the fine. And the black line is the daycare centers with them. But during the 5 first weeks, they just observed without the fine. So both groups had no fine. And as you can see, the amount of lateness is relatively similar. After the 5th week, they installed the fine here. What happened? Parents came more late than ever. Look. Why? Why does this happen? Why do you think?
Because paying the fine kind of validates being late in their head.
Yeah, a fine is a price. I mean, people have intrinsic motivation. I like to teach, for example. I would certainly teach. No, let's not say for free. Let's choose a different thing. But I like to do something. I like to play soccer. Yeah, and I'm willing to play soccer for free. But I said, well, Wesley, now I'm paying you 50 cents to play soccer. You see, my intrinsic motivation changes because of the price. Now I'm paying attention to how much I am earning to play soccer. And I'm not playing because I like to play. Children who like to draw, if you reward them, they stop drawing. They stop drawing because they pay attention to what they're being paid. So what happens is that, of course, parents were arriving late, but they didn't want to. They were trying to get on time, but they couldn't. They felt badly for not being enough on time. But since there is a fine, now they're thinking, oh, it's so cheap to arrive late, then we're going to arrive late. And that's what happened. So people are fair-minded. People have civic motives and whatever. And if you increase the incentives of people to behave self-interested, they'll be. So this is a bad incentive. But so after the fine, this group of parents arrived much more late. But after the 17th week, they removed the fine. It didn't go back to the initial position. They continued to stay late. So it's not so simple. Oh, if you're doing something bad, you have to pay something. You have to pay for it. If you do something bad, you have to pay. And of course, if the fine was really high, naturally they would stop arriving late. But that's not the point. The point is that it is not immediate. Right? It is not so simple to think about incentives this way. When you're putting money into something that doesn't need money, you may actually do worse than that. People will start paying attention to the money that you are paying or you are not paying, and stop thinking about how good it is or how bad it is to do something. Now, intertemporal choice. A lot of decisions that we make are based on doing something now or doing something in the future. One anomaly that happens then. So a group received this question: do you prefer $50 now or $100 a year from now? Most people chose the immediate reward. I prefer $50 now than $100 a year from now. Another group of people received these questions. Do you prefer $50 5 years from now or $100 6 years from now? Notice that the difference in time between these two options is the same. It's 1 year of difference. And this is what matters. If you prefer $50 now to $100 a year from now, you have to prefer $50 5 years from now than $100 6 years from now. But that's not what happens. People prefer the immediate reward in the short run, but in the long run, they are patient. They are willing to receive more money in the long run, but they prefer the immediate reward in the short run. And notice how this is inconsistent. So you have a choice between 50 now or 100 only. Or or between 50 5 years from now or 106 years from now. Okay? Let's take this situation. What do you prefer? $50 5 years from now or $100 6 years from now? Most people prefer $100 6 years from now. This one. I made my choice. This is my choice. Okay. It's sad. Time passes. You're waiting for the money. When it gets to this point, actually it's this choice, right? When you are 1 year from receiving this $100, you are facing this choice: $50 now or $100 a year from now. And what happens is that only as time passes, people change their decision.